Hello everyone, welcome to Mechanical Sati. Today we are going to discuss some MCQs on engineering mechanics. Previously we have uploaded some videos, that is two videos on engineering mechanics. So up to parallelogram law we have discussed. So in this video basically we'll be discussing some previous year asked question in SSC JEE from engineering mechanics. So we'll try to cover all the chapters from engineering mechanics because a less amount of questions are being asked from the engineering mechanics. So I think we can cover all these chapters. So be with me till last so that you can take maximum benefit from this video. So watch till last. Around 16 questions we'll be discussing here. So without wasting time, let us move forward and start our discussion. This is the first chapter, that is the system of forces. We'll study it in detail, but in this video we are going to discuss only some of the MCQs which were asked in different exam previously. So let us start it. So for that, here first question which was asked in SSC JEE 2014. So let us read it. So here two tensile forces, each of magnitude F, are acting at a point perpendicular to each other. So here if you will see, there are two tensile force which are acting at a single point, and the magnitude is given as capital F. Okay, so capital F is the magnitude of that force, and we need to find out the resultant of these two forces. Okay, so if I'll draw these two forces, then I can draw like this. So let this is a force, let this is force 1, and this is another force, let it this is the force 2, and we can say here it is given that magnitude of these two forces are F and F. So magnitude are equal for these two forces, and we need to find out the resultant of these two forces. So as it is telling that these two forces are acting at a single point, so we can apply the parallelogram law over here. So according to the parallelogram law, so if there will be any two forces which will be acting at a single point, or they are concurrent forces, then if we'll be constructing a parallelogram by taking these two forces, then the diagonal which will be constructing through that single point where it will be acting, that diagonal will be the resultant. Okay, so I think you have understood this one. Okay, so let us try to construct an or that construct a parallelogram over here by taking two forces. Okay, so these are two sides, another sides will be constructed here, another sides will be this one. As the magnitude of these force are F and F, so again this magnitude will be also F and F. Okay, so whatever diagonal, the diagonal which will be constructed, which will be passing through this common point, so we can draw a diagonal like this. So this diagonal will be the resultant for these two forces. So let I am naming this is as R. So now what we need to do, already we have known that this is the diagonal. Okay, so now we have to find out the magnitude of this R. Okay, so for that reason we can simply use the Pythagoras theorem in this triangle. So let me show that. Okay, so let me use the pointer over here. So we can use the Pythagoras theorem in this right angle triangle, or else we can use simply our parallelogram law and we can find out the resultant. So in both the ways we'll be trying to find out the value of R. Okay, so if I will be using the Pythagoras theorem in this triangle, so we know the value of this force is F, and again the magnitude of this force is also F. Then according to Pythagoras theorem, the resultant, or we can say that is the what, that is hypertension. Okay, hypotenuse. Okay, hypotenuse will be equal to perpendicular square plus your base square whole under root. Okay, so I can write F square plus f square, that will be equal to 2f square whole under root. So if I'll be writing, so I can write r will be equal to 2f square whole under root. Okay, so from this we can find out that r will be equal to root 2f. So here we can say, simply we can say option A will be the correct answer. Or else we can also apply the what our parallelogram law. So parallelogram law, what it is saying, that r will be equal to what, if there are two forces of a different magnitude, then it will be equal to, suppose any force is having magnitude p and other force is magnitude with q, then we can say that will be equal to under root of p square plus q square. So let me write this, that is p square plus q square plus 2pq cos theta, and theta is the angle in between these two forces. So here both the magnitude are same, so p and q can be replaced by f, so f square, so here we can apply f, and here also we can replace by f, so f square plus f square, so I can write it 2f square, okay, plus here theta value, that is the angle between these two forces, is 90 degree, so cos theta value we can say this will be equal to 0, and this total term will be equal to 0. Okay, so I can simply write 2f square, and this value we can find again, that is root 2f. So from here also we can get the value of resultant, that will be equal to root 2f. So I think you have understood this question. This is the simple one which was asked in 2014. So now let us move towards next question, that is question number 2. So let us read it. So if the x component of a force is negative, so here it is telling that the x component of a force is given as negative, and y component of that force again it is positive. Okay, so the direction of that force must lie in which quadrant? Okay, so suppose any force we are considering, so x component, so I can draw the quadrant over here. So this is the positive x direction, and this is the negative x, and this is the positive y, and this is the negative y. Okay, so this is the negative y. So x component of that force is negative, means the force is in this direction, and y component of that force is positive, means in this direction. So basically whatever force, okay, the direction of that force will lie in which quadrant. So simply we can say the direction will be somewhat in this direction. So we can say that direction of that force which having x component is having negative and y component is in the positive direction, that will be in the second quadrant. So here C option will be the correct answer. Okay, so here C option will be correct. Now let us move towards next question, that is question number 3. So what are the equilibrium conditions to be satisfied for a particle applied with a system of non-coplanar concurrent forces? Okay, so here it is telling that what are the equilibrium condition, okay, which is to be satisfied for a particle applied to the system of non-coplanar and concurrent. Okay, so concurrent means we can say they are acting at a single point, so that forces may be somewhat like this, and it may these are not non-coplanar, means they may not be in a single plane actually. So in this condition we have to consider all those forces along x and y and z, okay, will be equal to 0, that is summation of, okay, sum total of all those forces along x and y and z will be equal to 0. Again, as these are the non-coplanar forces, then we have to consider the moment also. So again summation of moment of x along x and along y and along z will be also equal to 0. So with our option, okay, with our answer option A is only matching, that is how your option A will be the correct one. So if it is it will be asking only about the concurrent forces, then we can say B option will be the correct one. But here it is concurrent as well as non-coplanar, so we can say your A option is the correct. That means summation of all forces will be equal to 0, as well as summation of all the moments will be also 0. Okay, so I think you have also understood this question. So now let us move towards next question, that is question number 4. So okay, so this much question we have got from the first chapter. So now let us move towards second chapter, that is free body diagram and equilibrium equations. So free body diagram, okay, so in detail we'll be studying later, but here we are only considering the questions which were asked previously. Okay, so question number 4, it was also asked in 2014 SSCG. So which law of motion of Newton gives the measure of force? Okay, so all of us know about Newton's laws of motion. So there are basically three laws: first law, second law, and third law. So among all these laws, your second law is telling about your force, because it is basically telling that if you try to define the statement according to your Newton's second law, the rate of change of momentum is directly proportional to force applied on any body. Okay, so whatever momentum, rate of change of momentum, that will be defined by the force. So your second law is giving some idea about force. Okay, so we will be trying to discuss or what idea will be getting from the first law, then we can get idea about inertia. Okay, so law of inertia also, it is being told that the first of law, Newton's first law, is also known as the law of inertia. And Newton's third law, so it is basically telling about the reaction forces. So action and reaction forces will be always equal. So these are three laws of Newton, of laws of motions, we can say. So among all these three laws, your second law, Newton's second law, is telling about the force. So here B option will be the correct answer. So let us move towards next question, that is question number 5. So effort lost in friction is a simple in a simple basis, sorry, that effort lost in friction, a simple machine, is what is the effort loss basically? So effort loss will be equal to what? That is P. So where P is the what? Actual effort. So I can write P is the, sorry, that is actual effort. Okay, actual effort. And your P dot or P naught. Okay, so P naught, I can write it as your ideal effort. Okay, so ideal effort. So here the what effort will be lost, that will be equal to what? Actual minus ideal, so that will be equal to P minus P naught. Okay, so you can remember this thing. Okay, or you can put some idea so that you can write it. So again, this was asked in 2014. So P minus P naught, so that is option D will be the correct answer in this question, that is question number 5. I think you have understood this one. So now let us move towards next question, that is question number 6. Which of the following theorem is used for the equilibrium of the body applied with three concurrent coplanar forces? So in the previous class we have discussed that it was concurrent force and non-coplanar forces. So in that case we have to put all these 6 equations, so that all the forces along x and y and z should be equal to 0, and all the moments along x and y and z will be equal to 0. But in this case it is concurrent and coplanar, it's not non-coplanar. Okay, so which equation or which theorem can be used for the equilibrium of the body? In this concurrent and coplanar forces. So Bernoulli's theorem, it can't be used. Hamilton's theorem, we cannot use. Pythagorean's theorem, it will never be used. But the Lami's theorem, it can be used for concurrent and coplanar forces. So we'll study all these theorems in detail in further classes, but you can remember in case of your concurrent and coplanar forces, we can use Lami's theorem. So now for this, now only you can remember this one. So we can study about this in detail in further classes. So now let us move towards next question, that is question number 7. Again, so we have completed the next chapter. So previous chapter we have completed. So next chapter is your friction. So maximum of question we can get from the friction also. This is one of the most important chapter in engineering mechanics. So we'll be studying all these things in detail. So no need to worry. If you have studied or you can answer, then it is good. So let us let us get an idea from this actually. So let us see how or what is the type of question which we may get from in the exam. So let us read it. The friction between objects that are stationary. Okay. So when an object is in the stationary position, that means it is in the rest position, then whatever friction will be there, that friction is known as what. Okay, so from the name only we can get idea about what will be the type of friction. So there are different types of friction like static, rolling, kinetic and dynamic. So kinetic and dynamic can never be, and rolling also it cannot be, because in this all type of friction your body or any object should move. That means it must not be any in your stationary position. So it can be the static friction. So when any object in the stationary position, that means in the rest position, whatever friction will be there, that friction is known as your static friction. So I think you have got idea about this also. So here A option will be the correct answer. Okay. So now let us move to our next question, that is question number 8. So the direction of a frictional force acting on a body which can slide on a fixed surface is what? Okay, so the direction, okay, we need to find out the direction actually. So the direction of frictional force acting on a body which can slide on a fixed surface. Suppose I am taking this is a fixed surface, and we need to find out the direction of frictional force. Okay, so let this is any body or this is any object, and it is being sliding with some velocity or some acceleration in this direction. Let it is being accelerated with this a, okay, and it is moving in the forward direction. Then what will be the direction of frictional force? So it will be opposite to it. Okay, so the direction of frictional force will be opposite to the direction of motion, the in which direction your body is going to move. So opposite to that your frictional force will be acting. So if we check all these options, so in the direction of motion, so it can be the answer. Normal to the direction of motion, so it cannot be the answer. Unpredictable, no, it can't be. It can be predictable, because we know that frictional force will be always acting on a body opposite to the direction of force. So opposite to the direction of motion. So here D option will be the correct one. All these three options will be wrong. So here D option will be the correct one, that is opposite to the direction of motion. Okay, so I think you have understood this one. So now let us move towards next question, that is question number 9. Let us read it. So a body of weight 30 Newton rests on a horizontal floor. Okay, so let me draw this diagram. So let this is any horizontal floor. Okay, and any body which is resting here, which is having a weight that is given as 30 Newton. Okay, so a gradually increasing horizontal force is applied to the body, which just starts moving when force is 9 Newton. Okay, so when your gradually applied force is reaching at 9 Newton, then your body, which is at rest previously, which was at rest previously, that starts moving. Okay, so the coefficient of friction between the body and the floor will be equal to what? So the gradually applied force, we can say let that is equal to F. Okay, and that will be equal to what? 9 Newton. And we need to find out the coefficient of friction between this body and this floor. Okay, so due to movement of this body, will be getting a frictional force in this direction. So let me use black color to show that. So we'll be getting a frictional force in opposite to the applied force or direction of motion. So if, as you have seen that the force is being applied in this direction, your motion will be also in this direction, so that your frictional force will be acting in this direction. So what will be that frictional force? That will be equal to what? So okay, so before that I can say a normal force will be acting upward, which will be equal to the value of 30 Newton, because every action has equal and opposite reaction, that we got to know in the from the your third law of motion. So we'll be getting, let this is Rn. So normal reaction will be getting here, which will be equal to again 30 Newton. Okay, so the frictional force will be, what will be getting here, that will be coefficient of friction, that equal to mu and into normal reaction. Okay, so the value of mu Rn, we can say, if we'll be putting the summation of x forces along x axis, x direction will be equal to 0, then we can say this force that equal to 9 Newton will be equal to this mu Rn. Okay, so this force will be equal to this value, that is the frictional force. That means applied force will be equal to frictional force. Okay, so I can write over here. So see here that F is equal to mu Rn. Okay, so this is n. So F is given to us, that is 9 Newton. Rn we can find out, that is equal to 30 Newton, and we need to find out the value of mu. So mu we can find out, that is equal to F by Rn, and F, the value of F and Rn we can simply put over here, that F is equal to 9 and Rn equal to 30. So 9 by 30 we can write it as 3 by 10. So you can see our answer is matching with option number 3, sorry B, option number B. So B will be the correct answer over here. So now let us move towards next question, that is question number 10. So let us read it. So a body of weight W is placed on a rough inclined plane. Okay, so any inclined plane is given, and W, any body of weight is given W is placed. So the inclination of plane is okay, so inclination of the plane with the horizontal is less than that of the angle of friction. So what will be the condition of body? We need to find out whether that body will be in equilibrium or move upward or move downward, or none of the above. So this was asked in SSC JEE 2014. So it was a good question, we can say. So let us try to find out the condition of body. So let me draw the diagram so that you can understand it properly. So let this is any inclined surface. So that inclination angle, let this is theta, and any body which is placed here. so that we'll be getting a weight force which will be downward. So weight of the body, we can say it is given W. So due to that weight, we'll be getting a reaction force which will be acting normal to this inclined surface. So let this reaction is N. Okay, so here it is telling that the inclination angle with horizontal, it is less than the friction angle, angle of friction. So first thing we need to understand what is what is the meaning of angle of friction first. So angle of friction means it is the angle in between your normal. Okay, so this is the normal. So angle in between the normal and the resultant of the normal force and frictional force. Okay, so suppose this is the body, and here we can say this is the weight which is acting downward. So this is the angle theta. Then if we'll be trying to calculate this angle, so let us try to calculate this angle also. So we can see if this is the triangle, so let me use the pointer over here. So this is the triangle, that is right angle triangle, because this is the normal, this is 90 degree. So we can say if this is theta, then this will be equal to what, 90 minus theta. Okay, so again if we'll be considering this triangle, so try to see this pointer. So this triangle what I am considering over here, so this is again right angle triangle, and this is 90 minus theta. So we can tell that this angle is also theta. So let me write it. So let me use another pointer, sorry, another pen. So this angle also we can calculate, that is theta. Okay, so this angle is also what, theta. Okay, so we can get a frictional force. Suppose if we'll be increasing this angle, then this body will be tending to move down. Okay, normally. So friction will be acting in this direction. So let this the friction force F, and we know that already in the previous problem we have discussed friction will be equal to what, mu into N, where mu is the coefficient of friction between these two bodies, that is your this body and this surface. This is the coefficient of friction. Okay, so we can say and if we'll be trying to resolve these components W. Okay, and W is acting at a theta angle to this normal. Okay, so the this component, okay, we can find that will be equal to W sine theta. Okay, that is W sine theta, and this component we can find out that will be equal to W cos theta. Okay, I think you have understood this one. So let me make you clear about this. So this is the direction of application of your W. So W is acting in this direction, and it is inclined theta degree to this line. Okay, so this is the theta to this line. So if we'll be trying to resolve this W in this direction, then we can resolve it by using the cos component. And if we'll be trying to resolve in this direction, then we can resolve by using the sine component. So now if we'll see, then this, okay, this force will be equal to the force of friction if we'll be using the summation of x or y equal to 0. Okay, so this will be equal to this, and this normal reaction will be equal to this. So we can write, so let me use the pointer over here. So we can write F will be equal to what, F will be equal to what, W sine theta, and N will be equal to what, N will be equal to what, W cos theta. Okay, and F is again what, that will be equal to what, mu into N. Okay, mu into reaction force. Okay, so if we be dividing these equations, okay, let this is the equation 1 and this is the equation 2. Okay, so if we dividing equation 1 divided by equation 2, then I can write, so let this is W sine theta divided by W cos theta. So W can be cancelled, so I can write tan theta. Okay, so tan theta, again here it is mu n, and here is again only n, so n can be cancelled, so we'll be getting mu. Okay, and if we'll be trying to calculate this theta, then I can calculate that will be equal to, theta will be equal to tan inverse mu. Okay, so this is the value of theta we can calculate. So sorry, so angle of friction, what I want to make you understand that angle of friction is the angle in between the resultant which will be obtained by your normal force, so this force and this friction. Okay, so it will be acting in somewhat in this direction. Okay, so this resultant will be getting here, so let this is the resultant, and whatever angle in between these two. Okay, so if this is the angle, let I am denoting by phi, so angle of friction I am denoting it is as phi. So if this angle and this angle, so this angle we know this is your f. Okay, so that is theta, and this is the inclined angle. Okay, so if this theta and phi are equal, okay, so this theta and phi are equal, then we can say your body will be in the equilibrium condition, because this and this can be, okay, in a single line, so the your body will be at equilibrium condition. But here it is telling that the okay, so again if will be increasing your, if will increase this theta above this phi angle, what will happen, this body, okay, this body, so let me use the pointer so you can understand. So this body will tend to move down. So listen me carefully. So if I am increasing this angle, so if I am increasing this angle more than this phi, then this body will tend to move down. But in this case, if we read, inclination of the plane with horizontal is less than the angle of friction, means we can write theta. Okay, so theta is less than phi, that means it will be in the equilibrium condition. So what we can learn over here, so agar if your this angle, that is angle inclination or inclined angle, is less than or equal to your friction angle, that is angle of friction, that means I can write theta, if theta is less than or equal to phi, then we can say this is the condition of equilibrium. But if theta will be greater than phi, then it will move down. Okay, so this one B option will be correct if it will be greater than phi. But in this case it will be in equilibrium, so your A option will be the correct answer. So here we can write A option will be the correct one. So I think you have understood this one. Okay, so now let us move towards next question, that is question number 11. So a body of mass 5 kg is pushed up to 2 meter on a smooth 30-degree inclined surface by a force that is 60 Newton acting parallel to the plane. Okay, so what will be the work done on the body? So we need to find out the work done on the body. So sorry, so let us draw the drawing over here. So this angle is given is 30 degree, and mass is given that is equal to 5 kg. Okay, and the distance which is being traveled by this body, that is equal to 2 meter. Okay, so this distance we can write at 2 meter. Okay, and okay, so this force, okay, inclined by force, so this force we can, it is given as 60 Newton, and it is parallel to the plane. Okay, so it is parallel to the plane. Okay, and weight is given as your 5 kg. So simply if we'll be putting the energy conservation equation, means when this body was in this height. Okay, so this height is unknown for us. So when this body adds okay, and when this body was at this height, okay, so what is the potential energy with it, that will be converted, and that we can say that is the work done on the body. Okay, so if we'll be trying to calculate the potential energy, then we can calculate that equal to mgh. Okay, and mass is given g we know, and if we can find out the value of h, then we can find out the potential energy, and that will be the equal to work done on the body. So let us try to calculate this height. This is given as 2 meter, so this is given as 2 meter, and this angle is given as 30 degrees. So if we'll be putting the sine 30 degree, then I can write this height, let this is h, so h divided by this. Okay, so this is the hypotenuse. Okay, so that will be equal to 2. Okay, and the h we can calculate, that will be equal to, so this we can multiply here, so 2 into sine 30. So sine 30 we know that will be equal to 1 by 2, and so here we can calculate h equal to 1 over here. So if we'll be putting all these values, so h is equal to 1, and m is given as 5 kg, and g is 9.81 we can put. So simply if we'll be putting all this in value, then we can find out the answer. So okay, so let us calculate this one. So here we can get a value that is 49.05, okay, and joule. Okay, but in any option we are not getting this value. So this, in this question sorry, you may get any grace mark. Okay, so answer will be getting that is 49.05 joule. Okay, so now let us move towards next question, that is question number 12. So a body of mass 5 kg accelerates at a constant rate. So acceleration is given on a smooth horizontal surface, and due to an external force acting at 30 degree with the horizontal. So magnitude of that force we need to calculate. So okay, so let me draw that diagram over here. So any body is there. Okay, so which is being accelerated at a is given, that is 2 meter per second square. So a is given 2 meter per second square, and what are other data? So weight of this body is given as, so mass is given, that is 5 kg, and a force is acting at 30 degree with horizontal. Okay, so external force, and we need to find out that force. Okay, so this force is being acting so that it is moving with the acceleration, that is a. So we know that the force is equal to what, m into a. Okay, mass into acceleration. So mass is given, and we need to find out the force. So let us try to calculate that force. Okay, so force here, if we'll be trying to calculate, then simply we can put the value of ma, and it will be, so this angle is given as 30 degree. I think it is 30 degree. Okay, it's 30 degree, and it will be resolving this component along this direction. So I can write that is equal to f cos, okay, cos 30. So this is the f cos 30, and this f cos 30 will be equal to m into a. Okay, so I can write f cos 30, okay, that is cos 30 will be equal to m into a, where m is equal to 5 into a is equal to 2, so I can get 10. Okay, so the value of f will be getting, that will be equal to what, that will be equal to 10 by sine 30, sine 30. So 10 by sine 30 will be the force. Let us check all these options. So option a, that is will be equal to correct answer, that is the okay, so let us check whether sine or cos. Okay, so this is the cos, sorry, so this is the cos 30. Okay, so this is a cos 30. So 10 by cos 30 newton. So this will be the wrong one, this will be the right one, that is c option will be the correct answer. C will be the correct answer over here. 10 by sine 30, sorry, cos 30 will be the correct answer. Okay, so now let us move towards next question, that is question number 13, which is from the chapter, that is work and energy. So a fan rotates at a constant speed. So n is given as 60 rpm. The total angular displacement it makes in 10 seconds. We need to find out angular displacement. That means we need to find out the angular displacement, that is denoted by theta. So how much radian it displaced when in 10 seconds. Okay, so it rotates 60 revolution in a minute. So if we'll be trying to convert into second, that is revolution per second, then I can do that by let 60, and per second, that I have to divide by 60. Okay, so 1 revolution per second we can get, so that is 1 revolution per second. Okay, so that total angular displacement in 10 second, so theta we can find out, that will be equal to, okay, 1 revolution will be equal to 2 pi. Okay, okay, so in a second it is being revolving 1 times, okay, 1 revolution, so we can say 2 pi. So in 10 second we can multiply with 10, so we'll be getting 20. Okay, so 25 radian will be the correct answer. So I think you have understood, or else let us try to repeat this. So 1 revolution, suppose it is being revolved once, that means it will cover 2 pi. Okay, so that means 1 revolution means 2 pi. Okay, 2 pi angular displacement. So in a second it is being 1 revolution, that means 2 pi radian it is being revolved, it is displaced, angular displacement, it is 2 pi. Then 2 sorry, in 10 second how much will be the angular displacement? So 2 pi into your 10, so we'll be getting, okay, that is 20 pi radian. Okay, so here we can say D option will be the correct answer. Okay, so now I think it's clear to you. So now let us move towards next question, that is question number 14. So the angle turned by a wheel while it starts from rest and accelerates at a constant rate, that is given 3 radian per second square. So alpha is given as 3 radian per second square, and interval of 20 seconds, so t is given as 20 seconds. Okay, so what is the angle turn we need to find out? So we need to find out the angle turn. What is the angle turn? Okay, let this is the theta. Okay, okay, we need to find out the angle turn by the wheel when it starts from rest and accelerates at a constant rate. Okay, so we can put this equation. Okay, let us try to write out that equation. So in the linear equation we write as s equal to ut plus half at t square. Okay, so in the form angular relation, if we try to write, then let me write it. So we need to find out to theta. So theta will be equal to what? Omega, that is angular velocity, u plus, okay, so omega plus half alpha t square. So it was first rest, so while it was rest first, so angular velocity will be equal to 0 in the initial condition. And let us put all these values. So alpha is given as 3 and time is given as 20 seconds, so simply we can put these values. So half into alpha is given 3 into okay, time is given 20, so 20 square. So this will be equal to 400. Okay, so divided by 2, so this will be equal to 200. Okay, and 200 into 3, so we'll be getting 600 as our answer. So simply you can calculate and you can find out 600 radian will be the correct answer. So here B option will be the correct answer. Okay, so now let us move towards next question, that is question number 15. Again, so this is another chapter, that is impulse, momentum and collision. Okay, so let us read it. A ball is dropped vertically downward. Okay, it hits the floor with a velocity is given 9 meter per second. Okay, and bounces to a distance, that is bounce distance is given as 1.2 meter. Okay, so coefficient of restitution between the floor and the ball is what? So we need to find out the coefficient of restitution over here. What are the data are given? So the ball dropped with a velocity, that velocity is given 9 meter per second, and the bounce distance is given 1.2 meter. So let us try to find out the coefficient of restitution here. So coefficient of restitution is basically denoted by E. And what is the formula? So formula is your velocity. So let me write it: velocity of rebound, okay, rebound divided by velocity of approach. Okay, so approach is ch, APPROS. Okay, so velocity of rebound divided by velocity of approach. So velocity of approach is given to us, and if you can calculate the velocity of rebound, then we can find out the coefficient of restitution. So let us find out the velocity of rebound here. So I can note it VR. Okay, so that can be calculated by this formula, so we can derive it later. So try to remember this for now. So that is equal to 2gh, and h is the your rebound distance, okay, bounce distance. Okay, so all these data are given over here. So h is given as 1.2 meter. So we can put this value, so 2 into g we can put 9.81, and h is we can put 1.2 and whole under root. So if we'll be calculating this value, then we can get 4.8 something. Okay, so simply you can put this value, and you can find out the value of velocity of your rebound. Okay, after finding this value, simply you can put in the formula what I had written before. Okay, so E will be equal to what? Velocity of rebound that we now calculate, that is equal to 4.8 something. So try to calculate the value, and your velocity of drop, that will be equal to 9, which is given to us. And if we'll be calculating this value, then we'll be getting, so we'll be getting the 0.54. so try to calculate and find out this value. So you will be getting 0.54. so here option A will be the correct answer. So now let us move towards next question, that is question number 16, and probably this is the last question. Okay, so the quantity which is equal to the rate of change of momentum is known as what? So this is one easy question. So the rate of change of momentum, simply it is the definition of second law of motion. So that is the force. So dp by dt. Okay, so dp by dt, that equal to force. Okay, or we can say it is directly proportional to force or force. Okay, so the rate of change of momentum is known as your force. Okay, so D option will be the correct answer for here. So with this we have reached at the end of lecture for today. So if you like these videos, then press on the like button which is given below, and if you are new here, then do subscribe it and press on the bell icon, so that you'll be getting all the notifications from our channel whenever we'll be uploading any video on this. So thank you for watching.